7.5, the Dirac delta function. Okay, so this has to do with like if you're hitting a golf ball or you're hitting a baseball and you have that that force that is struck quickly, like the ball will be struck quickly. So you have a piecewise function, kind of like a step function again, where you just have some type of force for a short period of time. So you can see like t sub 0 minus a to t sub 0 minus b, that short distance or short time is when the force is acted upon, right? So they call it a unit impulse. But the main thing that we want to know is this transformation. So the transform of the Dirac delta function will look like this. So if you have that t minus t naught, it'll just be e to the negative s times t naught. So again, with this, we are doing initial value problems, and if we get something that looks like this, and again, so let's apply the Laplace transform. So I'm going to get s squared capital Y of s minus s y of 0 minus y prime of 0 plus y of 0 equals, now the Laplace for this, we're just using that new notation I got, so it's 4e to the negative 2 pi s. Okay, and now same idea, right? You are just solving for y of s, so I'll get minus s y prime of 0 is 0. So y of s has to equal 4e to the negative 2 pi s over s squared plus 1 minus s over s squared plus 1. And now, just going backwards, right, so f of t is going to equal, so just eliminating this portion because that's our unit step, right, so that's u t minus 2 pi. The rest is just sine, so it's 4 sine, and then don't forget the t minus 2 pi. We can clean that up in a bit. And then minus, and here's our just cosine t. So here we get 4, if you're moving 2 pi units for sine, you still have just sine. So sine t, and then the unit function t minus 2 pi minus cosine, oh, that should be a plus cosine t. So really what we have here is a piecewise function, right? You could see there's your first part, cosine t from 0 to 2 pi, and then 4 sine t after 2 pi. So that's like same thing, same notation there. And that's basically it. So hopefully that helps for this week.